So, am I recording? Did it start? Yep. It started. Okay. So, sum of difference formulas, there's 1, 2, 3, 4, 5, 6 sum of difference formulas that we're not sure if we want you to memorize. Well, you should try to memorize it. So, sine of u plus v, and if you're interested in where these come from, you can look at the derivation of each one of these formulas. But they're kind of complicated, so if you don't care about it, just learn the formula. So sine of u plus v is equal to sine of u times cosine v, and just kind of write them down, and then we'll show you where they come from, or I will show you, not we. Plus cosine u sine of v. Let's see if I could do these without looking at my notes. Sine of u minus v equals sine of u times a cosine of v. Guess what comes next?
V.
Minus cosine u sine of v. Cosine of u plus v is equal to, so this one isn't as intuitive, cosine u cosine v minus sine u sine v. Okay, so the cosine of, and then cosine of u minus v is equal to cosine u cosine v plus sine u sine v. And then we have some ones for tangent. Tangent, that's 4 so far, right? Tangent of u plus v is equal to tan u plus tan v, sorry. Oh, there's my eraser thing, doesn't want tan v over 1 minus tan u tan v, and then tan u minus v is equal to tan u minus tan v over 1 plus tan u tan v. So what does all that mean? I'll tell you in a minute. But a way to remember them, I don't know. I always remember sine. Sine has a plus sign in between them. Yes, it's going to be on the test. Sine has a plus sign in between them if it's plus, and a minus sign in between them if it's minus. It always goes uv, 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 uv. Okay, so sine has a plus sign where the angles are being added, and a minus sign where the angles are being subtracted. Cosine is the opposite of what you would think it would be. So it goes cosine u, cosine, so cosine gets cosine, cosine, sine, sine, and sine goes sine, cosine, cosine, sine. I don't know, you can kind of, if you repeat it a few times, it might stick in your head. And so when you have subtracting the cosines, it goes, that symbol in the middle is a plus, and then tan of u plus v kind of has a plus sign up top and a minus sign on the bottom, and u minus v looks like that. Okay, so what the heck, who cares? What do you want to know? What do you want to do this for? Well, say they say find the exact value. I'm going to try to do it right here. Find the exact value. That means using the unit circle of cosine of 75. 75 degrees. So you know two angles. You have to think about two angles that either add or subtract to 75 degrees, that you know the sines and cosine of. Okay? Who knows two angles that you could add or subtract that you know the sine or cosine of?
45.
45 and
30. 45.
No, those don't add up to 70. They got to add up to 75. So 45 and what? 30, right? So you can use 45 and 30. You could use that's probably the easiest one.
15.
But you can't use 15 because you don't know the sine or cosine of 15. You could subtract angles. You could say the cosine of 120 minus 45. Does that give you 75? 120 minus, that would work as well. Okay? But, so you could do it a number of different ways depending on which you want to use, that's which formula you use. So let's think of it as the cosine of, that's equal, right, to the cosine of 75, sorry, that's wrong. Oh, my eraser doesn't work. Okay? That's equal to the cosine of 45 plus 30. And this, call this your u, and this your v. And then you just plug in to the cosine addition formula and you simplify. That's all you have to do. Okay? So you're going to plug into this one. So you're going to go the cosine. So this is equal to the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30. And then you just simplify that expression. Okay?
Is that minus?
Is that minus? Yes, because it's I'm using this formula. I'm using this formula right here. Right, for cosine of u plus v.
Why don't you use the other one?
See? Which one?
U minus v.
Because 45 plus 30 makes 75. Now, if I wanted 15, then I'd use a minus one. Right? Okay?
Yeah.
So then I just, cosine of 45, so this is where you got to know your unit circle. That's root of 2 over 2. That's 1/2. That's also root of 2 over 2. And that's, whoops, that's not 1/2. That's root of 3. Let's see if I can fix that. Ah, shoot. That's root, uh-oh. I'm going to mess up this whole thing. That's not 1/2. That's root of 3 over 2, right? Cosine of 30 is root of 3 over 2. And sine of 30 is 1/2. And then you just simplify. And when you have square roots, you root of 2 times root of 3 is root of 6. And 2 times 2 is 4. Okay? Minus root of 2 over 4. And the way you want to write this is root of 6 minus root of 2, that whole thing over 4. Alright? And that's your final answer. And you leave it like that. Alright? Now, just to show you that that is true, we can check on your graphing calculator. Looks like this kid left something in here. He's trying to get it. Do you need something, Chris? Did you leave something in here? Oh, I don't know. She's either in there, or she's in the office, or she's wandering around the hall somewhere. Okay. Okay. So, sorry about that. I just want to show you that this is true. Go away. Here. Stop doing weird stuff. Where'd my calculator go? There we go. Always impressed. So, so watch, just to show you that this is true. If I go second square root of 6, and you can't add square roots, so this is not equal to the square root of 4 over 4, right? Second square root of 6 minus second square root of 2 divided, so I'm going to hit enter just because I don't want to go back and put that, divided by 4, and I get 0.258819, okay? So now what if I want to do, I'm going to make sure I go to mode. I have to change to mode because I think I'm in radians from the last. I'm going to go to degrees now because I'm plugging in things in degrees. And if I want to find the cosine of 75, hopefully I did everything right, and I get the exact same thing. See? Okay? So that's the way that works. Okay, we're done. Not yet. All right. So what? Sorry. So
What does this class say?
35 when it's over. Okay. Second class. So go away. 90. just a thing. Okay. So we're gonna say I want to do sine. So now they want to do. You'll see something like this on your test. I promise you will. Let's do the one that you're gonna see on your. Now let's not do the exact same one. Let's do. You'll see some. Say I want to do sine of 5 pi over 12. Okay, and you say, oh crap, it's in. No, that's the same, isn't it? Let's not do 5 pi over 12. Let's do sine of, no, not 6 pi. You'll see things like sine, I'm just going to do pi over 12. You'll see pi over 12. Does anyone know how many degrees that is? That's 15 degrees. Because pi over 6 is 30 degrees. So you can kind of convert it in your head to 15 degrees. And then you have to say, well, 15 can be what two angles that I know the sine and cosine of? 45, right, 30, 45, 43. Oh my God.
Wait, are you getting that numbers?
45 minus 30 is probably what I want to do. Okay? Why? Because pi over 12 is 15 degrees, right? So I need two angles that I know the sine and cosine of. That will make 15 degrees. And I know the sine and cosine of 45. And so I can write this as, how's that taste? What's in there? I just let, you guys always seem to be drinking and trading drinks. You know, and I don't know
just thirsty.
what's going on.
I just
I don't know, it just seems like. Okay. All right. So, anyway.
You're drinking straight vodka in the house?
So another way I could write this is the sine of 45 is pi over what? Pi over what? 4 minus pi over 6. Okay? If you think in radians, you can think of this as how many pi's over 12 is that? 3 pi's over 12. 3 pi's over 12 minus, how many pi's over 12? 2 pi's over 12 would give you 1 pi over 12. Because then if I convert those two, that's the way I try to think about it. Try to think in terms of pi's over 12. Because 3 pi over 12 is pi over 4, and 2 pi over 12 is pi over 6. So anyway, now I'm going to use the sine addition formula. Sine of pi over 12, no, pi over 4. Pi over 4 times the cosine of pi over 6. Pi over 6. Sine has a minus sign in between. Minus the cosine. So sine goes sine, cosine, cosine, sine. Cosine of pi over 4 and sine of pi over 6. So it goes alpha, beta, just like that. And sine of pi over 4, you should get it d is root of 2 over 2. Cosine of pi over 6 is root of 3 over 2 minus root of 2 over 2 times 1/2. And you get root of 6 minus root of 2 over 4. That's always the answer. No, it's not. It's just that's, you know, a similar problem. But the answer does a lot of times look something like that. Okay? So that's how you do that. Questions? Problems? Answers? All right. I'm not done yet. So, can I move on? Done writing things down? Those of you who are paying attention, taking notes? Okay. Okay. All right. A tie. So say we have, find the exact value of sine of u.
You got water in my nose.
Yeah.
Given.
Yeah.
play. And cosine of u, cosine of v equals negative 12 over 15. And v is between
What's the zero?
pi over 2 and pi. Okay? So if you see something like this, which you will, this is how you do it. You have to draw two different pictures. Alright? So the first thing you do is you draw a picture for u, and then you draw a picture for v. So here's u. Which quadrant am I going to be in for this picture?
First one.
Which quadrant? U is between 0 and pi over 2. Which quadrant am I in?
First quadrant.
First quadrant. So I draw a picture over here. And I don't know what my angle is or anything, but I know that this is 4 and that is 5. And this is U right there. Okay? Then I draw a picture for V. This is how you have to do it to help you think about it. Which quadrant am I here in here? Second quadrant, because U is between pi over 2 and pi. And then you call this side negative 12, and you call the hypotenuse 13. So this angle right there is V. All right?
Wait, which
So
angle?
the angle from here to the terminal side of the ray. And then you do the Pythagorean theorem to find this side, which comes out to be what?
Pi.
What does this side come out to be? And what does this come out to be?
11.
You guys don't know this Pythagorean triple? Comes out to be 5. This is another Pythagorean triple. A lot of times they'll have nice, neat numbers that come out nice. Okay. Give me. Thanks. All right. So you have numbers that come out nice and neat like this, and then and then you just plug into the formula sine of u plus v. So I'm going to use sine of u, which is 4 over 5, cosine, sine, cosine, so cosine of v, which is negative 12 over 13. Sine has a plus sign in between. Cosine of u, you can have your formulas in front of you. Cosine of u, sine of v, which is negative 12 over 13 again, right? Sine of v. Yeah. Sine, cosine, cosine,
No,
sine. Oops, you're right. That'd be 5 over 3. Okay? So that'd be minus 5, no, positive 5. Positive 5 over 13, because this is positive in the second quadrant, this is negative. And then you just do the math. That's negative 48 over 65, I believe that is, plus 15 over 65, which comes out to be negative 33 over 65. And that's your final answer. That's all there is to it. Got it? That hard?
Why wouldn't you cross out the 5 and the 5?
Why wouldn't I cross out the 5 and 5? Because I want to keep a common denominator down here, because I want to add them together. I could, but then I'm going to have to, I want to combine them again at the end. So you're always going to end up with a common denominator down here, so I don't want to cancel out the 5 in that case.
Always?
Okay? Always. Yeah, always.
Not only do it.
Right? Okay.
Can we get these on the test?
What?
Like,
The
can we have
formula?
a cheat sheet with these things?
I don't know, maybe. We haven't decided yet. Okay. So, right. So, you'll see some stuff like this where they write cosine of arc. So, this is where they say, what the heck? Arc cosine of, oh, that should have been arc tangent. Arc tangent of 1 plus arc tangent arc cosine of x as an algebraic expression.
That is algebraic.
an expression that doesn't have sines and cosines. And again, this might be something just to work on trig identities, but also you might see something like this in calculus where you want to do that and change it into having no trig functions in there. So what you want to do is you want to call this like alpha and call this like beta over here. Okay? And so what you're going to be using is the cosine alpha plus beta formula. And to do that, first I'm going to draw a picture where tangent is equal to 1. Where is inverse tangent 1? What's the angle that I'm talking about? You guys know?
45.
Very good. 45 degrees. When that angle there is 45 degrees, tangent is, you could write it like this, 1 over 1, like that. And then you could do the Pythagorean theorem to find this is, that comes out to be square root of 2. Or you can say that's the angle whose tangent is 45. It still will come out the same. Okay? And this is root of 2 over 2. And this is root of 2 over 2. And this is 1. Both of these will work. Okay? Both of these pictures will give you the same ratios, right? The trig ratio here is
How'd you know
root
to
of 2.
draw that picture?
What?
How'd you know to draw that picture?
Because arc tangent is equal to 1. So I want the ratio of the opposite side to the adjacent side to be 1. Okay? And I want it to be in the first quadrant because arc tangent is positive in the first quadrant.
And the third.
Okay?
This other,
Not in the third, no. Tangent is positive in the third, but arc tangent is only positive in the first. Okay? Because that's an inverse, you have to restrict the range. Yes, ma'am.
Why is it like not an X? Why do you use that instead of X?
Because that's what they give me, 1, right?
No, the little, I don't know what it's called. The little fish thing.
Oh, I'm sorry.
Jesus.
So in my old book, we always used alphas and betas instead of U's and V's. I'm just using different letters. Instead of U and V, I'm using alphas and betas. Sorry.
Wait, which one's for which?
I call this alpha for angle A, and this is B, beta for angle B.
So B is B.
What about
B
the
is
zero?
the-
What about the zero with
yeah,
the line
alpha
through
is-
it?
What?
What is the zero with the line through it?
The 0 with the line through, where's that? This?
It was on the homework.
This? That's like that?
Yeah.
That's a phi, I think, just another phi, just another Greek letter that they use for angle. I call these alpha and beta, but
Wait,
What's
what does
beta?
that mean though? That zero with the line.
it just means, it's just another name for an angle, right? Okay.
What about
And-
the one you said got a fancy?
they're confusing people.
I don't know, let's just finish, all right? So our cosine is equal to x. Again, we'll draw this picture in the first quadrant, we'll call this x. Adjacent over hypotenuse, I'm going to call my hypotenuse 1. And then by the Pythagorean theorem, this comes out to be 1 minus x squared, if you do the math. All right? And then I'm going to plug into the formula cosine of alpha plus beta. So I want, well, we'll call it cosine alpha, cosine beta. I like alphas and betas better, okay? Minus sine alpha, sine beta. Let's not trash this yet, okay? And then we're gonna just plug in the numbers. So if I look at my alpha picture, cosine alpha is 1 over root of 2. Cosine of beta, they give me, right? Cosine of beta is x over 1, that's just x. Minus sine of alpha, which is 1 over root of 2, times the sine of beta, which is square root of 1 minus x squared over 1, right? Opposite over hypotenuse. And then I just simplify it a little bit. You get
How do you
x.
know to use that equation like cosine alpha for sine?
Because they're asking me what is the cosine of this. This represents some angle plus some other name.
Okay.
Okay? Okay? Minus square root
Wait, but
of,
how do you know to use minus? Why don't you use plus like that?
because that's what the formula says. Cosine alpha plus beta is cosine alpha cosine beta minus
Oh,
sine alpha.
okay.
Okay? Over x over root of 2. And you could just write that as x minus square root of 1 minus x squared over root of 2. And in the book, they don't rationalize the denominator. You could leave it like that if you want to. Okay? You got that? Good. I know it's not that exciting, but I don't know what to do. You could drop out of school and become a rock star.
Oh, we did your test back.
No, don't do that. Don't, I'm just kidding. What?
Did we did our test back?
Not yet. So we're going to do another one. So they do have little identity problems where they'll say something like, prove that cosine of pi over 2 minus x equals sine of x. All right? So this you just apply the sum of difference formulas. Let me go quick here. I'm going to do the cosine of alpha. This is like alpha, or sorry, I'll call it u and v's. I don't want to confuse you. I'm confusing myself. U and v. All right? So I'm going to use the cosine u minus v formula in this case. And all that's going to look like is going to go cosine of pi over 2 sine of, no, cosine of x plus sine of pi over 2 sine of x. And then you just simplify that. What's the cosine of pi over 2? Cosine of pi over 2. Quick! 0. What's 0 times anything? 0. So this will go away. What's the sine of pi over 2? 1. So you get 1 times the sine of x, which is just equal to sine of x. And then I'm done. Right? Okay. I think I just have one more. Find all solutions. Oh, that's not good one. Let's do this one.
Wait, why did you cross that off?
Because 0 times cosine turns into 0, right? This equals 0, so I don't need to, right? 0 times anything. Okay. Plus 27 minutes.
That was long.